So you're stuck on a somewhat tough limit and it just doesn't seem to be evaluating. So you're taking some kind of limit where x is approaching a, f of a over g of a. And, oh, my bad, not f of a, of f of x over g of x. And the problem is that f of a equals 0 and g of a equals 0. That's your problem here. So what can we do to fix this? Well, let's try something else. We'll keep the limit as x approaches a here, but we're also going to apply the limit as h approaches 0. Now our modified is going to be f of x plus h divided by g of x plus h. So as you see, when h approaches 0, it's going to be the same limit as before. So we haven't really done anything to it yet, per se. Okay, that's good. What else can we do here? Well, since the limit as x approaches a is what we're going to be using, and maybe we could try making this look a little bit more like the derivative. So we could have f of x plus h minus f of x, because when we limit this out to a, this f of a term is going to disappear and turn to 0 divided by g of x plus h minus g of x. So these lone terms on the side, they limit out to 0. So it's almost like we've done nothing by subtracting them, except just make it look more like the derivative. Okay, well, if we really want to make things look more like a derivative, let's add that divided by h by multiplying both the top and bottom by 1 over h. So that now gives us the limit as x approaches a, limit as h approaches 0, of f of x plus h minus f of x divided by h, all divided by g of x plus h minus g of x, all divided by h. So now, what we can see is that on top, this becomes f prime of x. On the bottom, this becomes g prime of x when we use that first limit here, limit as h approaches 0. So now, our final limit, let's write out what we started with. Final limit as x approaches a, of f of x over g of x equals limit as x approaches a for f prime of x over g prime of x. So now that we have this L'Hopital's rule established, let's see a quick example of how we could use this to find a quick limit. So let's take the problem where we're taking the limit x approaches 0 of 3x squared divided by the tangent of x. Well, let's take derivative of the top. Derivative of the top turns into 3 by 2x to the 1, which equals 6x. What's the derivative on the bottom? Well, in the examples video for trig derivatives, that was secant squared of x. So let's go and make that our new limit. Limit x approaches 0, 6x divided by secant squared of x. Well, secant squared of x, that's using the cosine. The cosine of 0 is 1. So 1 over 1 squared is still 1. So that bottom part turns to 1 when we take the limit, and on top that turns to 0 when we take the limit. So that leaves us with the statement that it equals 0 over 1 equals 0. It's also important to note that this relationship here, the fact that the derivative f prime of x equals the limit as h approaches 0, f of x plus h minus f of x. The fact that the derivative and the limit are tied together these two concepts are interlinked. It means that if you're ever having a tough time with this, maybe you should see how you can apply this to it using this rule. It doesn't have to be L'Hopital's rule, but you might be able to use the derivative in this definition of the derivative to take a limit. That's all for today. As always, keep on learning.